We have had 2 rounds of testing for 40 gig transponders on the NLR network so far. The first one was back in September from Seattle to Sunnyvale. Seattle to Sunnyvale, from the network perspective, actually is one of our more challenging routes. In particular, Portland to Sunnyvale represents our longest span that doesn't have add drop along it. So at least right now, there is a site in Northern California we could convert to an add drop if we need to. But at least right now, Portland to Sunnyvale is 1,300 kilometers. It's the longest light has to go without being able to be regenerated. And so that's why we chose it, us in conjunction with Darkstrand chose it as our first 40 gig test. Greg from Light River added a tremendous amount of help during this test, I should point out. We tested 3 vendors, Nortel, Equinox, and ADVA, with a variety of success. Then the other tests I'm going to talk about, Kevin and I and one other person from Cisco tested the first generation 40 gig muxponder from Atlanta to Washington in March. That span is also about 1,300 kilometers, though there's Raleigh and the other one, Charlotte. The test protocol for both tests was pretty much the same. We were testing, obviously, since 40 gig test sets aren't widely available. We used the 40 gig muxponder. We took a 10 gig test set, and we looped the client interfaces back on each other. So essentially, each bit went back and forth 4 times to get our 40 gig right over the line. So here's the same picture Ron showed. The 4-hump one here is Equinox. Their technology essentially is muxing together. I should say I am not. This update is going to be relatively brief. I am not going to stray into what I consider NDA territories. So when you ask questions at the end, I don't want to cross any NDA boundaries, certainly. But I'm pretty sure everything I'm going to say is publicly available. So the Equinox solution is to have 4 10 gig waves very closely spaced together. This more solid hump is ADVA. They use the adaptive PQSK that Ron mentioned. And the double hump is the Nortel solution, though I don't know. Obviously, since they're talks with Sienna, I don't know if they're going to progress along this line or if they're going to change direction. So I don't even know if the card they tested with is going to be available. But in a sense, it doesn't matter because the Nortel card didn't work on our network. The Nortel card didn't work. Ron mentioned this earlier, and I'll reiterate. You notice that the Nortel card had 2 humps. They were using 2 bipolar waves right next to each other. And the Equinox kind of worked over a very short distance. And both of these results are actually related. If you have waves that close together and you have a network with no dispersion, the waves stay that close together. And you have a nonlinear effect called cross-phase modulation. And so essentially the waves start interfering with each other and cause bit errors on each of the adjacent waves. The ADVA, since it doesn't rely on multiple waves, either 2 or 4, actually worked really very well. We didn't see any post-FEC bit errors. We saw a relatively low pre-FEC error rate.
And That's right alongside all the production waves.
Yes.
The full dispersion compensation is still in play.
Yeah, it's the regular production Sunnyvale to Seattle network. As Ron pointed out, the Equinops was actually right up against a regular production wave. I don't recall whose wave that was. I'm sorry, Dave. But yes, it was the regular in production network with no changes to the dispersion compensation or the common optronics. So I'll talk a little more in depth about the Cisco test. We tested from Atlanta to Washington, again with the first gen 40 gig muxponder. To be honest, after the dark strand test, I think we, as an organization, learned a lot about doing these sorts of tests in general. So we were a lot more cautious before proceeding. We actually went into CTP. We modeled the wave. We got a model from Cisco. We put it in the design. We tried to predict ahead of time a little better what the impact on the system will be and if the wave has a chance of working. We tested a couple different wavelengths. 1534.2, and I realize this is really hard to read, even for me standing right next to it. 34.2 is actually the bottom one. You notice there's a bit of red in there.
Down in that area is where
Okay, great.
That indicates the OSNR margin for that particular wavelength with this particular modulation scheme is a little marginal. And then the other wavelength we tested was higher, 1558.9. And you can see there it's still below, officially passing, but only barely. So we hooked in true NLR fashion, we threw the cards in, we plugged them in, we hooked them up. After a few minutes, the trunk synced, and it actually was working fine. This is on 58.9. So again, the wavelength we expect to work a little better. The yellow alarm is just a threshold thing. It's not an actual alarm. We did, as I mentioned, we had a bit error rate tester. So we were running data. We weren't just, kind of staring at the blinky light, so to speak. We did run a significant number of bits through it. We did, on each wavelength, we did a shorter test just to make sure we would, it would work okay. On 58.9, we got a relatively low error rate. Again, this is Atlanta to Washington on the production NLR network with no changes to the dispersion or optronics. What?
You said a low error rate.
A low prefect error rate. And I was hoping these would turn out a little better, but I apologize that they didn't. You can see this is the bit errors field. You can see that there's a number at the top. The bottom field, which is 0, is the uncorrectable words. So it is only prefect errors. We don't see any actual bit errors once the prefect algorithm is done with it. So we got about 500,000 errors a second on 58.9. On 34.2, as predicted, was not as good a wavelength for this modulation. But again, there are no post-spec errors. All the errors were corrected. The prefect error rate is slightly higher. And so we wanted to be sure So we left the test set on overnight, about 17 hours. We came back the next morning, no uncorrectables.